Hey guys, this is going to be the last video in our unit over solving inequalities. We will be doing some word problems a little bit next week before your test. But in this last video I want to talk about how to solve absolute value inequalities. And if you remember anything about absolute value equations, this is going to be very similar to how we solved equations. There's just going to be one additional thing because they're inequalities that you have to watch out for. So similar to our equations, when you see an absolute value inequality, that's just going to be an inequality with a variable inside an absolute value sign. Okay, so this is a basic example of what an absolute value inequality would look like. This is the absolute value of 2x minus 1 is less than 5. And if you remember for equations, this would have been an equal sign right here. And as soon as you get the absolute value part isolated, you then write two separate equations. Well, for inequalities, we're going to do the same thing. We're going to write two separate inequalities. One of the inequalities you write is going to be exactly the inequality you see, just without the absolute value bars. So when I get down to this point in a problem, I would write 2x minus 1 is less than 5. My other inequality is going to be 2x minus 1 as well. Just like an equation, you're going to make the other side, the right side of the inequality, the opposite of this number or the expression you see. So if you see a positive 5, we'll make this a negative 5 over here. But there's going to be one key difference. For inequalities, you're always going to flip the sign in the second inequality. So instead of writing a less than for this one, we're going to write a greater than sign. So this is the thing that you need to watch out for. When you rewrite your inequalities, you will always flip the inequality sign of your second inequality. Okay? There is one other detail we want to watch out for, and that is setting up the correct type of compound inequality. So each of these absolute value problems we do is going to involve two inequalities, and we know from the last couple of videos that when you have two inequalities in the same problem, it's called a compound inequality. And so compound inequalities, you know, can be joined by one of two words, either the word and or the word or. And it, again, matters which word goes in between because and or mean two different things. So if you have this as the format, if you have an absolute value, okay, I'm just going to, for simplicity, I'm going to say the absolute value of x. But if your absolute value expression is on the left side and you have a less than sign, okay, and then it doesn't matter what's over here. If you have a less than sign with the absolute value part being on the left, you're always going to use the and in between. If you have an absolute value expression on the left and you have a greater than sign, then you're always going to use the word or in between your inequalities. So a less than sign or a less than or equal to, okay, you're going to use the word and. A greater than sign or a greater than or equal to, you're going to use the word or in between. The way I remember this is I remember that a greater than sounds kind of like great or than. So if you think of it as great or than, that's going to remind you to use or. And then if you think about less than, if you just emphasize the and part of that, less than, then you'll remember to use and then. So less than, great or than is the way I remember which sign to use. Okay, one last thing before we get to some examples. So the basic rules of thumb, again, to solve absolute value inequalities, just to summarize, is once you isolate the absolute value bars, or once you isolate the absolute value expression, you're going to rewrite the problem as a compound inequality without your absolute value symbols, and you want to remember to flip your second inequality sign. So now let's jump to the back side and take a look at these four examples. Number one, I have the absolute value of 3x minus 4 is less than or equal to 8. My absolute value expression is already isolated for this problem, so right away I'm going to write two separate inequalities. My first inequality is just going to be 3x minus 4 is less than or equal to 8. Exactly what you see up here, just no absolute value bars. Your second inequality is going to be 3x minus 4. You're going to flip the inequality sign, so you'll make this a greater than or equal to, and then you're going to do the opposite of positive 8, which is negative 8. So your second inequality will be 3x minus 4 is greater than or equal to negative 8. In between, you're going to put either the word and you're going to get that word from this inequality sign right here. What's the inequality sign when your absolute value expression is on the left side. This is a less than, and so going back to your chart over here, we know that less than, we use the word and in between. So this is going to be an and compound inequality. Okay, so now I'm going to solve both of these inequalities separately. So you can add 4 to both sides, and you get 3x is less than or equal to 12, and then divide both sides by 3. X is less than or equal to 4 for this one. Over here, I'm going to do the same thing, add 4 to both sides. 3x is greater than or equal to negative 4, and then divide both sides by 3, and you get x is greater than or equal to negative 4/3. Okay, so we have the inequality now, x is less than or equal to 4, and x is greater than or equal to negative 4/3. And now I'm going to go ahead and graph this on a number line. Okay, so I'm going to start this at negative 2 and go to 5. That'll be enough room for both of my numbers on here. So negative 2, negative 1, 0, 1, 2, 3, 4, and 5. So we're going to do a closed dot on 4, and then that would be shaded to the left. And then here we're going to do a closed dot on negative 4/3, which is about negative 1 1/3. So that would be about right here. Just a little left of negative 1. Shade everything greater than that, so everything to the right. This is an and inequality, so you just need to make sure you're shading the overlap or the crossover region. So that's going to be on the actual number line. Everything between these two closed dots. So everything in between negative 4/3 and positive 4. Okay, now we're going to look at number 2. So in number 2, you have the absolute value of 5x plus 10 is greater than 15. So since your absolute value expression is isolated, you're going to write compound inequality now. Your first inequality will be 5x plus 10 is greater than 15. Your second inequality is going to be 5x plus 10. Flip the inequality sign, so less than, and then make 15 negative, so that'd be negative 15. And now you have to put the word in between. This time we have a greater than sign, so anytime you have a greater than sign, you're going to use the word or, great or than. So 5x plus 10 is greater than 15, or 5x plus 10 is less than negative 15. I'd like you to hit pause on this video and then try solving this one on your own. Graph it, and then click play to check your answer, please. Okay, so for this one, when you solve your compound inequality, you should get x is greater than 1 or x is less than negative 5. And so your graph is going to look like mine, hopefully. I went by 2's, and so I put open dots on 1, which is between 0 and 2, and negative 5, which is between negative 4 and negative 6, and your shading should be going in opposite directions for this one. So again, this is your final answer. No need to condense that answer. Okay, now let's take a look at number 3. For this one here, our absolute value expression is not isolated at the beginning of the problem. So the first thing I need to do before I rewrite anything is add 5 on both sides. So I'm going to add 5 here and here. And now I get the expression absolute value of 2x plus 2 is less than 20. Okay, so now I'm going to rewrite it as a compound inequality. 2x plus 2 is less than 20. 2x plus 2 is greater than negative 20. And the word that goes between is an and. Since this is a less than right here, I get to throw the word and in between. Go ahead and pause the video, solve this on your own, graph it, and then click play to check your answer, please. Okay, for this one, you should have the inequality x is less than 9 and x is greater than negative 11. Okay, so when I graph this, I'm putting open dots on 9 and negative 11. I went by 3's on my number line just to make it a little bit shorter. And so you're going to shade the area where you see some crossover, and that's going to be in between these two open circles. So everything in between negative 11 and 9 should be shaded. Okay, last one. Let's take a look at number 4. So for this one, again, I need to do a little bit of work before I can rewrite my inequality as a compound. I need to isolate this part right here, the absolute value of x minus 7. So I'm going to subtract 3 first from both sides. So I'm going to have a greater than or equal to 8x. This would be minus 8 when I combine my like terms on the right side. And then negative 4 times the absolute value of x minus 7 over here. And then I can divide both sides by negative 4. Remember to divide every term by negative 4, so on the left side and then here and here on the right side. That's going to give me the absolute value of x minus 7. And then I'm dividing both sides by a negative, so I need to flip my inequality sign here to a less than or equal to. So this becomes a less than or equal to negative 2x plus 2. So be really careful with your signs here when you're doing this. Less than or equal to negative 2x plus 2. Now that my absolute value is isolated, I can rewrite this as a compound inequality. So this is going to be x minus 7 is less than or equal to negative 2x plus 2. My other inequality is going to be x minus 7 is greater than or equal to. Make sure you take the opposites of both of these signs here. So that would be 2x, positive 2x, minus 2. Remember, we're multiplying this whole side here by negative 1. So each term, the negative 2x and the plus 2, gets the opposite sign on this second one. Okay, the word that goes in between, you're going to go off of this sign right here. Okay, again, you're going off the sign once the absolute value part is isolated. Okay, so don't go off the original sign. Go off this sign right here. Okay, and that sign right here is a less than or equal to, so that means you're going to use another and in between. Okay, so be really careful, make sure you're going off the right sign. It's in this step right here, once your absolute value part is isolated. So we're going to put the word and in between, and now I'll go ahead and solve both of these. If you want, you can go ahead and pause the video, try this on your own, and then click play to check your answer. So go ahead and do that now, please. Okay, so now let's go ahead and check your answer on this. When you solve both of these inequalities, you should get x is less than or equal to 3 and x is less than or equal to negative 5. You can check your work up here with mine. And so the graph of this is going to look like this. Both of your shadings are going to be going to the left. Okay, closed dots in both 3 and negative 5. This is an and though, so you're looking for where the crossover is. The crossover is only right here. So it's only going to be all of the numbers that are less than or equal to negative 5. So this is what the graph should look like. And then this is a condensed answer. X is less than or equal to only negative 5. Okay, feel free to go back and watch anything in this video that you need to. Write down a couple of questions if you'd like to ask them next time we see each other. Until then, have a nice day. You're all wonderful people. Take care.